So chapter 2, section 3 is applying deductive reasoning. So yesterday we dealt with inductive reasoning. Inductive was all about looking at patterns. I see a pattern, so I look at it and I figure out what's going to come next based on that pattern. So when we're talking about deductive reasoning, we're talking about using facts, definitions, accepted properties, and the laws of logic to form a logical argument. So this isn't just because I have seen something happen, so that is what's most likely to happen. These are based on the laws that we know. If Mr. Hire drops, if Mr. Hire lets go of a ball, then it will drop to the ground. That is deductive reasoning because we know, why is that ball going to fall to the ground after I let go of it? Gravity. We understand things that I go, that is a fact. I mean, now we could talk about like, oh, well, what about magic tricks and stuff? I go, but let's just talk about the real laws of science here for a minute, and that there's certain things that we know that's not going to happen. If that ball didn't hit the ground, we would literally have like a team of investigators here going, what the heck is going on? Like something is different. We need to change our whole thought process. So these are all based on facts, definition, and accepted properties. The way I usually look at it is if it's about seeing a pattern, if you're just looking at a pattern, that's inductive. Otherwise, if I'm using logic, if I'm using facts and definitions, because that's the definition of something, that's deductive reasoning. All right, so here we get into the law of detachment. And it says if the hypothesis of a conditional statement is true, remember that is the P part. If this part is true, then the conclusion is also true. So notice that we have a statement here that says if P then Q. Remember, that's what that means. If P is true, then Q will be true. That's what that means. If it's Friday, notice there is my hypothesis right there, then I eat pizza. There is my Q. Notice again, if was not included in the hypothesis, then was not included in the conclusion. If it's Friday, then I eat pizza. So let's say that I gave you the piece of information that, in fact, today is Friday. Then what can you deduce from that? Using logic, what could you assume is going to happen today because today is Friday? Yes, ma'am. What? Yeah, I will eat pizza today. Because the law of detachment says if the first thing is true, then the second thing will also be true. Because if you give me a conditional statement, if P then Q, and the P thing happens, then the Q thing will happen as well. Today is Friday, well then I will eat pizza. That is called the law of detachment. You're going to be asked to use both the law of detachment and another law that we're going to see in just a minute. So you're going to actually need to know this name up top. That's important here, not just what it is. You're going to need to know, oh, law of detachment is the one that says if the first thing is true, then the second thing is true. Is that raising your hand or just checking out your nails? Okay, you were like.
Is there anything where there would be special circumstances?
No, because even if this statement didn't make sense, somebody is making a statement. If P, then Q. Like, for example, if I said, if I wake up today, then I will have magic superpowers. My job is not to analyze like whether that's even in the realm of possibility. There's a statement here in the law of detachment says if the first one is true, then the second one is true. So if the first part happened, then we can assume the next part is going to happen as well. That's using the law of detachment. And now we get into the law of syllogism. This is a very tough word for most people. They kind of don't know how to pronounce it. So the word is syllogism. And it's used when the conclusion of one statement is the hypothesis of the other statement. And basically what we're doing is we're going to take two conditional statements and join them together. So watch what I'm going to do here is that I've got two conditional statements. The first one is right. I don't want to use up all my colors here. Let me go with highlighter. So the first one is right here, if P then Q. And then there's a second one that says if Q then R. And it means that if P happens, then Q will happen. And then there's another situation that if Q happens, then R will happen. So here's how it looks. If, I wanted my pencil tool. If it's Friday, there's my P, then I go to the movies. There's my Q. Now notice something interesting about the next statement. If I go to the movies, notice that's the exact same statement we had in the other one. That is the cue from the other one. That is the exact same thing. Those blue things, I underline them both in blue because those are the exact same statements. If it's Friday, then I go to the movies. Now the next statement says, if I go to the movies, then I eat popcorn. Oh, I shouldn't have underlined then. I eat popcorn. So really what we've got here is a series of events. If it's Friday, then I'm going to go to the movies. And if I go to the movies, then I'm going to eat popcorn. So we're going to take all of this and smush it together, and we're going to say, well, if the first thing happens, then the second thing will happen. And if the second thing is going to happen, then the third thing will happen. It will take us all the way down the line. So we can actually make this very short. If the first thing happens, then the last thing is going to happen. So if it's Friday, I'm going to go to the movies. And if I go to the movies, then I'm going to eat popcorn. So it means that if it's Friday, I'm going to eat popcorn. Now, we all know why I'm going to eat popcorn, because I'm actually at the movies. But what we've done is we've dropped that middle part. That is the law of syllogism. We don't need to make this big, long sentence. We just know that if it's Friday, I'm going to... Oh, I shouldn't have done that in blue. That I was using green. Sorry. Then I eat popcorn. Now all my colors match. So really what it looks like is this. If P, then Q. We have this first statement. Oh, clean that up. If P, then Q. And we have another statement that says, if Q, then R. And notice that these two things are exactly the same. So we're just going to bring them together and say, if P happens, then Q happens. And if Q happens, then, and sorry, it's still early. I don't know why I used a capital R there. I didn't intend that. It's just the coffee hasn't sunk into my brain yet. So if the first thing happens, the second thing will happen. And if the second thing happens, then the third thing will happen. So the shortest way to say this by the law of syllogism is if P happens, then R will happen. It took me from the first thing all the way down to the end. Questions on that? Because this is usually the area where people are like, wait, what?
Is the part you underline in green your R?
Yes. Yeah. So, yeah, I'm sorry. I should have written that underneath there. There's my R. So if P happens, I can give you an example. If I wake up late, then I will not have time to make coffee. If I don't make coffee, then I'm going to be a lousy teacher that day. So if I wake up late, then I will be a lousy teacher that day. Now we all understand that, well, wait, why would you be a lousy teacher that day? Because it really, for me, depends on the coffee. That's what keeps me going. That's what makes me talking a million miles an hour for you guys.
So in the conclusion, you would skip the, like for that one, you skip the if I go to the movies, and you go straight to the R.
Right, because if the first thing is true, right, if it's Friday, let's say today's Friday, then guess what I'm doing? I'm going to the movies, and guess what happens if I go to the movies? Then I'm going to eat popcorn. So it must be true that if it's Friday, then I'm going to eat popcorn. We can skip that middle step there and take it all the way to the end. The logic will lead you all the way to the end. Yes, ma'am? It doesn't really, we don't ever have one that wraps around, because if it kept wrapping around, we would never stop. It would be a circle. It'd be like, if this happens, like if I punched him, then he would punch her, and she would punch me, and then I would punch it. Like, it would just never stop. So we kind of need these sentences to have an ending. Now, this seems really bizarre why we're doing this, but again, this is where we're going with proofs. We're going to use math and be able to shorten a whole lot of math statements, and we're going to say, oh, that's the law of syllogism. The law of syllogism, well, how did you throw away I go to the movies? Because of the law of syllogism. That allows me. These are the explanations to say, I don't even need to say I go to the movies. Why? Because if P is true, then Q will be true, and if Q will be true, then R will also be true. All right. So here's what we've got. If, I always like to do this. I always like to underline my ifs and thens. Why do you think that I do that? What is my purpose?
So that you can define like which one is your hypothesis and which one is your conclusion.
Good. So notice here that that's kind of a messy thing to look at. This is like, wait, what? What's going on? But I saw my if 90 degrees is less than M, angle R is less than 180. So I think that's two things. It should be like if those things are both true, there's my P, then R is obtuse. The measure of angle R is 155. Oh, I see what they're saying. I'm sorry. That's not one. That's not two statements. Here's what we've got. This should really just be together. They're saying the measure of angle r. If the measure of angle r is greater than 90 degrees and it's less than 180 degrees, then it is obtuse, right? Because an angle that's greater than 90 degrees and less than 180 degrees would be obtuse, right? It's not a right angle. It's greater than 90, but it's less than 180. Then it's definitely obtuse. So if that is true, if the first part is true, then the second part will be true. Well, notice right here they gave us a statement. The measure of angle r is 155 degrees. Does that match this right here? Yes, because 155 is a number that is greater than 90, but it's less than 180. So this is good to go. So if that's good to go, what must be true about angle r? It's obtuse. Now you might be like, well, I just know that 155 degrees is obtuse. Yes, but you used logic to get there this time. Instead of just using like just a straight definition, you said, I use the information there that if angle r is between 90 and 180, then it must be obtuse. And they gave me the piece of information that angle r is 155, then using the law of detachment that says if the first thing is true, well then it must be that the second thing is also true. So the statement that we can make is that the angle r is obtuse. That is the statement we can make. We know that to be true. Why? Because you told me that the first thing is true, and the law of detachment says if the first thing is true, well then the second thing must be true.
Why didn't you underline angle r in blue also?
Oh, I did. So notice that they made a statement there. If P, then Q. And then what they're saying here is that this saying that the measure of angle R is 155 degrees, that's not exactly the same statement. They didn't word it exactly the same way as this, but we know that those two things mean there. It said, if the measure of angle R is between 90 degrees and 180 degrees, and they made a statement that is not the exact same words, but it fits that definition. So that's why I didn't like highlight it, underline it in red. It's not the exact same words. However, being 155 degrees does fall within the range of 90 to 180 degrees. So we know angle R is obtuse. All right, if Janelle gets a job, let me just do my little thing here. If I do these things and they may seem silly, but they're strategies that I see you guys use on the test as well. And I see that the people who get in the habit of doing this actually just blow these things out of the park. They're not even an issue for them because they just look at this and go, okay, I know exactly where this is going. Okay, so if Janelle gets a job, then she can afford a car. If P, then Q. If Janelle can afford a car, have we heard that statement before?
Yeah, that's cute.
That is our Q. I'm so glad you said that. There is our Q again. So I'm not going to call it a new letter. That's Q. It's the exact same thing we already said. If Q happens, then she will drive to school. So I'm going to use a new color here, and I'm going to call that R. It's a new thing. There's three things happening. Janelle getting a job, affording a car, and driving to school. If Janelle gets a job, she can afford a car. If she can afford a car, then she will drive to school. Using the law of syllogism, and remember the law of syllogism looks like this. If P is true, then Q must be true. And if Q, that's a G, if Q is true, well then it must be true that R is true. So we can make this statement. If P is true, then Q, and if Q is true, then R. And one last shortening right here, we just go, if P is true, then R is true. If the first thing is true, then the last thing must be true, because this series of events says the first thing leads to the second, and the second thing leads to the third. So now let's decide, using the law of syllogism, we are going to make an if-then statement, and we can drop some things out of here. Yes, sir? Okay, so here's our P, if P, so if Janelle gets a job, if P, then, and I'm sorry, what'd you say we're doing after that? Then she will drive to school. Sorry, I know that green isn't great on the eyes, but hopefully, she will drive to school. So notice what we did was we dropped that blue part in the middle because logically we didn't need to name every step. If the first thing is true, then the last thing is also going to be true. Because if she gets a job, then she can afford a car. Well, if she can afford a car, well, then she's going to use it to drive to school. So, whereas the law of detachment just says if the first thing is true, the second thing is true, syllogism says the first thing is true, well, then the second thing is true. And if the second thing is true, then the third thing is true. It brings all those ideas together into one shorter statement there. When it comes to your being assessed on this for quizzes and tests, one of the things that you're going to have to do on this one is there's going to be a lot of things that are vocab based. That it's like, using the law of syllogism, what statement can you make from this sentence? And I would give you a sentence maybe, and you have to shorten it using syllogism to the first thing leading to the second, and the second thing leading to the third. Now, with syllogism, this is super important. Notice that that blue line had to be there. Because watch me mess it up here. I'm going to mess it up. If Janelle gets a job, then she can afford a car. If Janelle gets new shoes, then she will drive to school. You can't join those things together because that second statement isn't the same. So if she gets a job, then she can afford a car, great. Then there's another statement that says if she gets new shoes, she will drive to school. Getting a new car and getting new shoes, there was nothing that joined those together.
So is that called something or?
That's the law of syllogism. It's called the law of syllogism. The other one is just incorrect. It's incorrect logic. There's nothing that says that will happen. There's kind of these two random ideas, and there was nothing to link them together. For example, you guys have all had this situation before, whereas you probably have a friend right now that you met through a mutual friend. Like, oh, I met this person through somebody else. So you both had something in common. You were both friends with person X, and now you two are friends because you had something in common that joined you. These two statements have something in common that join them. Yes, ma'am. Then you would say there's nothing you can do with them. There's no logic. There's no statements you can make because there's no logic that connects them. If I said, if I wake up late today, then I will have a bad day. And then I tell you, I got some mail from my mom this morning. What conclusion can you make? Nothing. There's no logic that said anything about mail from my mom. You gave me a rule about waking up late. Mail from my mom wasn't in there. All right, so now we're going to decide. It says state the law of logic. What we mean there is either detachment or syllogism. We're looking for one of those two things, that we're going to call it one of those two things, but we've got to read it and decide. Now watch what I do here is I'm going to use that same strategy I've always used. If you get an A or better on your math test, then you can go to the movies. If you go to the movies, notice, why did I use blue twice again?
Because it's cute.
Same statement, same exact statement. I'm not putting the P's and Q's on there now because I don't think we need them every single time, but then you can watch your favorite actor. So they have taken that and then they have made a new statement that says, if you get an A or better on your math test, then you can watch your favorite actor. Which one of those two laws does that match? Syllogism. Because we're bringing more than one idea, two separate ideas together. There are two different statements that have been joined together by this idea of going to the movies. If I get an A or better, I'm going to the movies. Well, if I go to the movies, then I can watch my favorite actor. So let's join those two things and drop the middle part. All right, so again, it gets a little trickier when we see numbers, but don't change what you're doing. Just let's look at this. Even if it's what is this? State the law of logic that is illustrated. So our answer is either going to be syllogism or it's going to be detachment. Let me just underline my ifs and thens because that always helps me out. Then, if x is greater than 12, then x plus 9 will be greater than 20. The value of x is 14. Now, that's not a statement I've seen before. That's not an if, then they're just telling me that the value of x is 14. Why did they tell me that x is 14? What was the purpose of that? They made that statement. What what was the purpose? What am I doing with that information?
So that you can like plug it in and see if it's true.
I could plug it in, but what does that have to do with logic? I could just do that with an equation. I didn't need logic for that.
It doesn't have anything to do with it. So it'd be
Really? It doesn't have anything to do with P or Q?
I mean, it doesn't state either.
Take a moment, and look at that dark underline, like the black line there that is underlined multiple times, and try to make a connection between P or Q. I don't care which one.
Well, that statement would be false, because the second half doesn't make sense to, I mean, when you plug it in, it's not right.
It's true. It's the law of detachment.
Okay, so talk to me about why it's the law of detachment then, because I think a lot of us are having a hard time seeing it. Why?
Because x is greater than 12 if x is 14, and if you plug in x in the conclusion side as well, it's greater than 20.
Okay, so remember they gave us a condition. If this happens, if you hit your brother, then you're grounded. If x is greater than 12, well, guess what? X is greater than 12. It says so right there. That's true. So forget about plugging it in. Do we agree that the law of detachment says that if this is true over here, then the second thing must be true, right? So I didn't do any plugging in. I'm not even going to verify it because the law of detachment, you just said, not you, the geometry universe out there said, just state the law. Well, the law says if the first thing is true, then the second thing must also be true. It doesn't say anything about false. It just says if the first thing's true, it's going to be the second one is true. And we actually have verified right here that this is true. Colette.
But like, I don't understand why those things have to be changed.
Okay, so let's for a moment just look at this, right? So there's really not two equations because actually this right here is exactly the same as that, yeah? Exactly the same thing. There's no difference between those two. Would you agree? Okay, so it says if x is greater than 12, then x plus 9 will be greater than 20. That's the statement they made. But then they go to give us one piece of information. They're saying the value of x is 14. Would you agree that that matches exactly what we said over here when we said if x is greater than 12? Well, 14 is greater than 12. I can use logic to say 14 is greater than 12, and now I know the first thing is true, so I don't care about plugging in. I know the second thing is true because that was the logical statement that was made.
But in order to know that the second thing is true, you would have to plug in to see that both are true. So even though you did it.
So wait, let me change it from numbers for a minute. If you do really well on your test, I will be a happy teacher. Okay, so you did really well on your test. What do you expect?
When you're a happy teacher.
Are you testing that? Are you doing some sort of are you, but there's a statement there, right? So you know if I do well on my test, then he will be a happy teacher. That's my statement I made. So I did well on my test, so you're happy. Like that's it. So we don't need to plug it in. You could plug it in if you want, but it doesn't matter because the law of detachment says it's true. So when we have a statement like this, we're not going through and testing the numbers out to see whether it's true. There was a statement. The statement was made. If x is greater than 12, then x plus 9 will be greater than 20. So if we check that, okay, great, x is 14, therefore this is true. All right, so, yep, want me to go back?
Deductive reasoning uses facts and definition, but inductive, what is it?
By watching patterns, by things that I have observed. For example, I'm going to tell you something right now, and this may apply to you, it may not. Every day you've seen me, I wait for you guys at the door, and I am eyeballing you up and down. I like to say hello to you, but really what I'm doing, the secret thing, is I'm checking your uniform. I'm making sure. I like to say hello to you anyway. I like you as people. But if something needs fixing, I'd rather we fix it at the door and just be cool right there. But there's something else going on. Now, what I'm doing is there are certain people that I know that even fourth quarter, every single day, I'm going to stop them at the door. I'm going to be like, please come stand in the non-VIP section until you have your pass on, you know? Like, I'm going to mess with them every day because I see a pattern of them. And it's only for me, like using inductive reasoning, when I see those people every single day who don't have their IDs on and I haven't seen them yet, I'm like, oh, Well, here it's a period, so guess what? I know this person is going to show up without their ID, and I'm going to have to put them over to the side. That's not like any sort of logic other than me watching a pattern and going, well, I know what's going to happen now because I do this every single day and I see it every single day. That's just about patterns.
But wouldn't that be both because deductive reasoning is based on fact? And you know for
Is it a fact that person will not show up at my door without their ID? Is it a fact? No. And actually, as soon as I say that to them, if I were to say to any student in here, you show up every day at my classroom without your ID, it is a fact that you won't have it tomorrow. I bet you what, they'll put it right in my face the next day. They will show up with the ID, they're going to have it like this and walk by and put it right in my face. Why? Because y'all love to do that. And I don't blame you for it. It's not a fact. A fact was something that will be true in every single circumstance. And if there's one circumstance that doesn't match it, we can't call it a fact. Whereas I'm talking about a pattern. You know patterns, like you kind of can predict things that happen. We all predict things. Like if you see somebody who looks like they're like a little bit sketchy coming down the road, like on the same side as you, it doesn't mean that there's anything wrong with them, but maybe there's part of you that just goes, oh, I know this pattern. I'm going to go ahead and walk over here because something doesn't seem right.
But isn't that using your logic also?
It's still logic. It's still logic, but it's not based on like facts. Like, let's face it, people make judgments on each other all the time. They're not based on facts. Sometimes they're based on feelings and they're based on illogical things, but they're based on other things. All right, so we're going to decide whether inductive, meaning watching a pattern, or deductive reasoning is used to reach the conclusion. Now, be very careful here. It's all about the wording, and we must explain it. Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball in the air, it will return to the ground. Now be careful. Don't put your own things in here. Think about what's being said there. Think about the phrase there, because I know what people want to say, but I want you to talk about what it says there. Yes, ma'am?
It's inductive.
I would say inductive too, even though we all know that's gravity. We all know it's gravity. But it didn't mention gravity anywhere in there, so talk to me about why you said inductive.
Because each time Monica kicks the ball, it returns to the ground, so it's a pattern.
It's a pattern. They're talking about there. Each time she does it, each time she kicks in the air, it returns to the ground. It didn't say Monica understands that gravity will pull the ball back to the ground each time. That would be all about logic. She understands by observing. And if you think about it, you probably understood gravity before anyone explained it to you. You understood that by accidents sometime, that when you drop things, they break if they hit the ground because they're going to be pulled to the ground by gravity. You understood that by observing a pattern, which is inductive reasoning. So it's talking there, each time Monica does it, it returns to the ground. That is an observation statement. Now the next one, all reptiles are cold-blooded. That is a factual statement. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Yes, ma'am?
Are they deductive because it's a factual statement?
We have a fact there. All reptiles are cold-blooded. That's a fact. Parrots are not cold-blooded. That is another fact. Using facts, I can put it together that a parrot is not a reptile. Even if you didn't know, like probably most of you knew that a parrot wasn't a reptile. But if you didn't know, with that information, you could make the conclusion. You go, they're not cold-blooded, and all reptiles are cold-blooded. So anything that's got warm blood cannot be a reptile. So if you don't have cold blood, you can't be a reptile. Yes, ma'am.
Okay, so instead of saying that this uses facts, could you say that it's deductive because it uses the law of syllogism because it does?
Well, so if syllogism has to have a joining middle idea. All reptiles are cold-blooded. Parrots are not cold-blooded. That's one of them is saying are, one of them is saying not. It's really not the same statement. We're using logic to put that together. Like you could, let's say we introduced a new animal to you and you knew that. Let's say it's a new animal we've never seen. We don't even know what to call it. But the only statement they gave you about it is that this animal is warm-blooded. What is a guaranteed statement you could make about it? That it's not a reptile. We can't say it's a mammal. But we could, I know, I thought we were going, but that's okay, that's a good thought. But the statement that a guaranteed statement we can make, it's not a reptile. Doesn't meet that criteria. We used logic to do that. We all imagined a different animal there. We all kind of built something in our mind what it might look like. But the one thing that would be true for all of us, not a reptile. Even if in your mind it looked like a reptile, it's not, because it's not cold-blooded. So we're using logic there. And that's it, my friends.